So what you can see here is a yogurt supply chain simulator that simulates a supply chain with a central manufacturing site and 3 decentralized warehouses that can be seen as a supermarket. Consumers, they show up at the end warehouses, so the supermarkets, and purchase yogurt according to their preferences. Consumers can choose between strawberry, blueberry, and apple yogurt, and some of the consumers prefer only strawberry, while some consumers, for example, accept blueberry as an alternative. Other consumers might prefer blueberry, but might also accept strawberry. And then there are some consumers that only accept blueberry, and some consumers that only accept apple yogurt. The warehouses, so to say, the supermarkets, purchase according to a randomly distributed purchasing program their yogurt from the central manufacturing plant, whereas the manufacturing plant produces onto stock according to a randomly distributed production schedule. So here on the manufacturing data, it's for example possible to change the mean daily production output and the shares of the different product lines. On the consumer demand data, you can, for example, here in this app change the mean daily demand per supermarket and the share of the different consumer preferences. You can also choose whether consumer demand is modeled using a Gaussian normal distribution. If this is false, then a log normal distribution will be used instead. The same is true for the manufacturing site. Here you can also choose between a Gaussian normal distribution and a log normal distribution. The log normal distribution will be used if this parameter is false. Then you can also, for example, specify the purchasing program of the warehouses, as well as the number of warehouses, and you can specify the delivery lead time between the manufacturing plant and the warehouses. There's also a product data type where you can specify the validity duration of a product. So after this duration, the product will be expired and has to be eliminated from stock. And the simulation simulates this entire supply chain. So the manufacturing onto stock, the purchasing from the warehouses or supermarkets, and then eventually the consumption by the consumers that show up at the supermarkets. And in this basic model, the inventory policy is always first in, first out. And then there's some exemplary statistics that are visualized whenever you run this model. For example, you can see here the total amount of yogurt units shipped per day by the central manufacturer. Here's the number of the total number of yogurt units sold to consumers at the various warehouses. So these are the 3 supermarkets in this case, and you can see the central manufacturer, how much the central manufacturer ships to all of the warehouses in total by product group. And you can also see the availability. So if you, for example, here look at strawberry, this chart shows over the duration of the simulation how many satisfied sales took place in amount of yogurt units at all of the supermarkets for consumers that have the preference only strawberry. The chart here shows the same availability chart for consumers that prefer strawberry but also accept blueberry, and so on. We have the same here for blueberry. So there's some consumers that only accept blueberry, while some prefer blueberry but accept strawberry. And lastly, we have some consumers that only accept apple. And now we can change the parameters of the simulation. For example, we could change the validity of the product. So let's say we set this to 14 days, and then we run the simulation again. It didn't have a strong impact here, so we still have some consumers throughout the simulation that show up at the supermarkets and that are not able to satisfy their need for apple yogurt, and on the other side, the supermarket is thus not able to make a successful sale. and loses revenue in this case. If we go back to the product, we can try to set down this parameter to, for example, 1 week and run the simulation again. So in this case, the products expire early, and this will have a negative impact on availability. We can see there has been a slightly negative impact, but if we try to reduce this further, let's say we, just for sake of demonstration, we set it down to 3 days validity, then we can see there's a much bigger availability issue in that case. That is, of course, because the warehouses have a delivery lead time. So let's try to set the delivery lead time down to 0. And let's run the simulation again. Then we can see the situation has improved, but we still have some unavailability here at the supermarkets in terms of Apple products. And if we look at the manufacturing output, we can see currently the manufacturer is producing the same amount of strawberry, blueberry, and apple yogurt, whereas the consumers actually, the largest preference group is only apple. So if we adjust the production program, we say 30% of the yogurt is strawberry, 30% is blueberry, and 40% is apple, and we run the simulation again, then the availability situation in terms of apple yogurt has improved. We also look at the other charts here to have improved. So this is an exemplary template. The technology behind is a SimPy simulation library that I developed in Python, and then on top of that a Shiny app using R. But I can also make this available as a web app so that you only have to use the interface. I can also customize this model and the underlying supply chain network, the underlying purchasing policies, inventory policies, whatever. You can add additional KPIs to this. If you're interested in that, you can contact me. And as I said, I can also make it available as a web app so that you don't have to execute the underlying source code. But in the link in the video description, you can go to my shop on my blog, where I also made this entire project and the app available as an R Python project, downloadable as a zip file.